Hello guys, in today's video I'm gonna show you how to make an economic valuation with a script created in Python. Most of the time MineSight, specifically the tools developed within Economic Planner, doesn't allow us to add certain variables to the model. For example, what would happen if we had mineral contaminants like arsenic, pyrite, and so on and so forth. That's gonna take a toll on the processing cost for sure, so it gotta be discounted on the block model. However, we don't have a variable input cell in MineSight to add this extra processing cost, so that's why we might use some other ways to come up with a customized valuation that fits in our economic block model. In the following minutes, I will show you how to evaluate a block model that has arsenic as a contaminant. So without further ado, let's jump into it. Okay, as you can see, we have already created a block model that has certain variables. If we carry one block, we will see the variables. For instance, we have the topography, the percentage of the block that is within the surface, the density, category, total Cooper recovery, the percentage of arsenic, the extra processing cost, and some other important variables. The destination, discounted profit, revenue, processing cost, mining cost, and the last but not least, the profit per ton. Then we have some economic assumptions, as you can see here. The processing cost, that it says that consider a penalty of 3.5 US dollars per ton for every 0.001% of arsenic. What does it mean? It means that if we have a block with 0.005% of arsenic, this block will have an extra processing cost of 7 US dollars per ton. Then we have the mining cost, an incremental cost as we go deeper and deeper for the ore and for the waste. Here we have some economic variables as well. The discount rate, that is 10%, processing cost, mining cost, copper recovery, foundry cost, refinery cost, concentrator and transportation cost, and copper price at a time. So okay, our first objective is to find out the extra processing cost. This one. We're going to do it by using a MineSight tool by the name of model calculation tool. We open it up. Okay. Here we can select all the variables that we are going to deal with. I have checked this box because this variable is going to be written. Okay, here we have a little piece of code that says if the block is greater or equal to 0.003% of arsenic, the extra processing cost is going to be this line. The percentage of arsenic minus the arsenic limit multiplied by 1000 and multiplied by 3.5 US dollar per ton. Otherwise, there is no extra processing cost. Okay, let's verify the syntax and it's good, and we run it. By the way, this block model has up to 1 million blocks, so it's done. We can check that out. We can carry one block. Okay, and we have the extra processing cost. So let's see. Here we have a 0.004% of arsenic. That means that is greater than the limit of 0.003%. That 0.001% accounts for 3.5 US dollars per ton. So it's okay. Then we can run another script. So here we have the script to calculate the other variables. As you can see, we have just imported some MineSight modules and Python libraries as well, as you can see here. Of course, I'm not gonna show you the entire script because it's kinda long, but it's nearly the same as the previous one. Here we are dealing with the block model and the project control files. Here we have some variables, some input variables: density, topography, category, copper, arsenic, copper recovery, and the extra processing cost for arsenic. Then the output variables: discounted profit, revenue, processing cost, mining cost, destination, profit per ton, and some extra ones. Okay, we can run this script. This is going to take a while because it's doing it bench after bench. I'll be back when it's done. Okay, we are back. It just finished running the script, so now we are going to verify all the calculated fields by using an Excel spreadsheet. Here we have a Excel spreadsheet, going to be pretty helpful. Here we are going to copy all the values from our block model and check out if we get the same outcomes. Okay, let's put it right here, and let's carry one block, for example this one. Let's copy all the required values into the spreadsheet. Okay, level 69, row 64, column 85. Then we've got the density, which is 2.552, the volume or the percentage of the block that is within the surface, which is 100%, category, number 3, total copper 0.24, copper recovery 0, and the percentage of arsenic, which is 0.006%. Okay, we are good. Here we have the copper price. Here it is the mining cost for ore and for waste respectively. Then the bench that it starts with the incremental cost, the subtotal mining cost, and here we have the penalty for arsenic, which is in this case 10.5 US dollar per ton, the processing cost, and here we have the downstream unit cost. We suppose that we are going to have a sinking rate of 8 benches per year. So that means that we're going to have a 1.25 discount factor. Here we have the block size, which is 25 by 25 by 18. Total tons. There is no recovery for this block, neither recoverable copper as well. Mining cost, the process cost, and the results. Here we can see that there is no difference. Okay, then the profit is 96,953. The processing cost is the same, but this one is positive. The destination is 1. Profit per ton 3.3 minus 3.3, and we are good. We can see that there is no significant difference between the calculated fields and the Excel calculated values. So now that we already have the economic model, we can continue running the Lerch and Grossman or the South-of-Law algorithm to get the ultimate bit limit and the mining sequence. So I think that's it for today's video. I hope you enjoyed, and don't forget to like and subscribe to the channel. Peace out.